Welcome back to another video. Today we're going to be talking about adding and subtracting fractions with different denominators. So if you recall last time we discussed we have a fraction a over c and another fraction with the same denominator b over c. Then we can just add the tops, the numerators, and keep the denominator. We're going to use this concept still with fractions with different denominators, and I'll show you how we do that. So notice that, let's say we have a fraction a over b, or we'll start with an example. Let's say we have a fraction 1/3 or 2/3. Let's do 2/3. Now, if we take 2/3 and multiply it by 1, we haven't done anything, right? It's still 2/3, still equal. Now, if we rewrite 1 in a different way, let's say we rewrite it as 4 over 4. We again haven't changed anything because we're still just multiplying 2/3 by 1. And we know how to multiply fractions. Multiply the top, multiply the bottom. We'll get 2 times 4 is 8 on top. 3 times 4 is 12 on bottom. So what we have is a string of equalities, which basically tells us that 2/3 is equal to 18 over 12. Right, and we've seen this in reverse. We went from 8/12 to 2/3, right, reducing or simplifying. But now we can kind of change the denominators now as we need in order to rewrite fractions into equivalent forms to get the denominators. So, for example, let's say we have 2/3 plus 1/12. Well, we know that we can't add these directly, but what we can do is rewrite 2/3 as 8/12 plus 1/12. And now we can add these just as before, which is 9 over 12. 9 is 3 times 3. 12 is 3 times 4. We can divide out one of the 3's. And we're left with 3/4. So we're going to take this concept of equivalent fractions to give ourselves the same denominator, what's called the least common denominator, or LCD, in order to add fractions. So the way we're going to do this in practice is going to, let's say you have, I don't know, 1/6 plus 1/8. I like to use the fact that the least common multiple of two numbers is equal to the product of those numbers divided by the greatest common divisor of those numbers. So 6 times 8, we know, is 48. The greatest common divisor of 6 and 8 is 2, because 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, so 2 works. And just a brief note on how we calculate the greatest common divisor, in case you don't remember. 6 is 2 times 3. 8. 8 is 2 times 4, which is 2 times 2. And we pair them up. We have 1, 2 in common, so that's our greatest common divisor. If we had, for example, 9, if we did 6 and 9, that's 3 times 3. Then it would be the 3 in common. If we had, let's say 12, that's going to be 2 times 6, which is 2 times 3. And you can see that now we have a 2 in common and a 3 in common, so the greatest common divisor would be 6. All right. So 42 divided by 8 is 24. I'm writing in blue. 24. So now what we're going to do is we're going to make each one of these fractions have a denominator of 24. So what can we multiply 6 by? 1/6 by, 6 on the denominator to give us 24. So 24 divided by 6 is 4. So we need to multiply by 1, so it has to be 4 over 4. So that's going to give us 4 over 24. And then same thing with 1/8. What can we multiply 8 by to give us 24? And the answer is 3. 3 over 24. So 1/6 plus 1/8 is going to be, well, 1/6 is just 4 over 24. 1/8 is just 3 over 24. We know how to add those. 4 plus 3, still all over 24. That gives us 7 over 24. That's as reduced as it gets. So we've added these together, and we can tell that our answer is 7 over 24. Let's do another. Let's do 3/4 plus 1/6 plus 5/8. So the least common multiple of 4, 6, and 8 is going to be 4 times 6 times 8 divided by the greatest common divisor of 4, 6, and 8. 6 times 4 is 24. 24 times 8 is 16, 17, 18, 19, 92. Where's my eraser? There it is. And the greatest common, actually this only, I should mention, this only works for 2 numbers. So sorry, ignore that. What we're gonna do is get a common denominator for any 2 of them. Let's do that. Least common multiple of 4 and 6 is going to be 4 times 6 divided by the greatest common divisor of 4 and 6. 6 times 4 is 24. The greatest common divisor of 4 and 6, is going to be 2. So we got 12. So these two are the common denominator is 12. Let's go ahead and deal with that first. What can we multiply 3/4 by to give us something over 12? Well, 4 times 3. And what about 1/6? To give us something over 12, it's going to be 2. So 3/4 plus 1/6 is going to be 9/12 plus 2/12, which is 11/12. Okay, but we're not done yet because we still have to add to 5/8. So the least common multiple, we have something over 12. Let me do this maybe in green. We have something over 12 and something over 8. So the least common multiple of 12 and 8, 12 times 8 is 96, divided by the greatest common divisor of 12 and 8, which is going to be 4, is 14? No, 24, sorry. So we need a common denominator of 24. So 11 over 12 plus, 11 over 12 times what is going to give us something over 24? And the answer is 2. So we get 22 over 24. And then, what's the other one? 5 over 8 times what is going to give us something over 24? The answer is 3. 15 over 24. And let me see if I can squeeze this in down here. We have 22. Let me start back this way. 3/4 plus 1/6 plus 5/8. Well, we know 3/4 plus 1/6 is 11/12 plus 5/8. We know that's 11/12 is the same thing as 22 over 24. 5/8 is the same thing as 15 over 24. That's going to give us 37 over 24 as our answer. So this is 37 over 24. Okay, let's do a couple more examples. Go back to one with 2. 3/5 minus negative x on 8. Okay, we have to get a common denominator here. So the least common multiple, 5 and 8, is going to give us 5 times 8, which is 40, divided by the greatest common divisor of 5 and 8, which is 1. So 40 is going to be the least common multiple. So 3 times, 3/5 times what is going to give us something over 40? The answer is 8. And we have x over 8. So 8 times what is going to give us something over 40? The answer is 5. So now we have 3/5 minus negative x over 8. Well, we can simplify that and say 3/5 minus a negative is the same thing as a plus x over 8, which is going to be 24 over 40 plus 5x over 40, which is going to be 5x plus 24 all over 40. Okay, let's do another one, kind of just like it, 3/5 minus, let's do plus 2 over x. Well, the least common multiple of 5 and x, we don't know. We know it's going to be 5x over the greatest common divisor of 5 and x, but it's this piece that we don't know, and we're not going to be able to know with x. So instead, we're going to have to just use the denominator 5 times x, because 5, if we, let me show you, if we multiply this by x over x, then the top becomes 3x, the denominator becomes 5x. And if we multiply 2 over x by 5 over 5, so I should note that there's 5, that's where this came from, and here is x, which is where that comes from. It's going to give us 10 over 5x. That's kind of the best we can do. We can't, once we have the value for x, then we can calculate the greatest common divisor, we can simplify later. But since we don't have that value for x, we can't do anything with it other than just get the denominator being the two denominators multiplied together. So we have 3/5 plus 2 over x is going to be 3x over 5x plus 10 over 5x, which is 3x plus 10 all over 5x. Okay, and we'll do one more example, which is going to be 8a squared plus c, where a is a third and c is a quarter. PEMDAS says we do exponent first, so a squared is a third squared, which is a third times a third, which is a ninth. And so then 8a squared is going to be 8 times 1/9, which is 8/9. And then 8a squared plus c is 8/9 plus c, which is a quarter. Common denominator here, you can verify, is going to be 36. So what do we multiply 9 by to get 36? It's going to be 4. So that's going to be 32 over 36. What do we multiply 4 by? It's 8. So 8. We get 40 over 36. Let's see, 40. I'll go ahead and do the factor tree here. 40 is 2 times 20, which is going to be 2 times 10, which is going to be 2 times 5. 36 is 2 times 18, which is going to be 2 times 9, which is going to be 3 times 3. Find the common stuff. We have a 2 and a 2. We have a 2 and a 2. That's it. So we can take those out. And on the top, we're left with 2 times 5. On the bottom, we're left with 3 times 3. Otherwise known as 10 over 9. Okay, that's going to be everything for this lecture, and that actually finishes up our module for fractions. Next, I believe we're doing the module for real numbers.